Hey, everybody, this is Ken Rose, and welcome back to the Level Up podcast, where we talk to some of the brightest engineering and DevOps leaders about what it takes to build great products, teams, and companies. Today, I am so happy to be joined by Lawrence Jones, who is the first engineer at Incident.io. Incident.io is an incident management platform that helps teams fix incidents faster. Before starting at Incident.io, Lawrence worked for 6.5 years at GoCardless, a global payment processor that includes TripAdvisor, DocuSign, and the UK government as customers. Lawrence, thank you so much for joining us.
Hey, it's great to be here and very flattered to be included in the people that you've been interviewing. So, happy to chat.
Awesome. So you joined Instant.io as their first engineer, and there's 30 plus people now. I was wondering if you could tell our listeners just a little bit about that journey.
So I think it's been quite a fun journey for me. So to be clear, I think when I was at GoCardless, I think when I first joined the company, there were about 35 people there. And then by the time I left, it was about 750 or so. So I think I'd always wanted to do the early stages of a startup. What I didn't realize joining Incident anyway was that those early stages would take all of about 12 months to go through. So that's been kind of a rocket ship growth that I think we're very grateful to have had, but has been quite a wild ride. It's been really interesting because I think I went from being a principal site reliability engineer or software engineer at GoCardless to coming in and being alongside three awesome founders, but also the first employee and trying to figure out how my impact would change there and the type of work that I could do here that was highly leveraged and would be delivering the value that I should for the company. So it's been a real kind of adjustment and one that I've actually quite enjoyed. Definitely going back to really building stuff and less of the leading and coordination of teams, but rapidly approaching the part where that coordination stuff is going to come in handy. So yeah.
What do you see as some of the major changes from when you were 4 people to now that you're 30? And what do you think kind of happens next as you get to 300 or the next kind of order of magnitude larger?
Yeah, so I think everyone always says you start in the same room, right? And we did. It was myself, Stephen, and Pete at least to start, and we just sat in a room in an old fire station, which was always a nice curiosity for an instant company. But yeah, at that point, you really are just very dialed into everything that's going on in the company because you can see the calls that people are on, you know the sales deals that you're looking at, you talk constantly about how you're going to evolve the product, and there's no demarcation between who is kind of directing where the product direction is going to go, so what product features we should be looking at or what avenues we should explore. It's kind of everyone is in it to kind of get the company into the best place that you can, rather than having predefined roles where they start thinking a bit more about, I'm just doing this part of the engineering or this part of the project, and there's other stuff going on outside of my remit that, I'll come back after a 2-week holiday and suddenly other stuff has happened. There's new product features and everything has kind of changed. But equally, it's great actually ending up with what I think is a really, really awesome product team that we've got at Incident, probably one of the best I've ever worked with. We are shipping stuff at the speed of light, and that's really exciting. And we also have a kind of uniquely close relationship with our customers. So Slack Connect channels directly with anyone who uses us. It means that I think primarily if a customer has a problem, they're usually going to be talking directly to the engineer that built the thing, and probably within about half an hour, if not more, or if not shorter. It also means you can kind of turn around and ship kind of delightful features for people, and I think that's an experience that people aren't used to, where they go, oh, hey, there's a problem here, and you're like, hold on for a second. Half an hour later, you're like, okay, it's fixed, or you've got this new feature now, have a good day. People are usually a bit gobsmacked with that, and it always feels really good to deliver that type of value.
100%. We actually do a similar thing at Ops Level. We have Slack Connect with all of our customers, and I find it also just helps build empathy among the engineering teams, especially as you scale your organization.
Oh yeah, people are always talking about the tool that you're building, and they're the people that you're trying to build this for. So trying to build an understanding of what it is that they're struggling with, or kind of not necessarily the solution that they're suggesting, because often people come with, I have a problem, and it's kind of your job to interpret the solution rather than necessarily building exactly what the person says that they need. You're kind of digging a bit deeper and trying to figure it out. But that context is essential if you want to build an intuition around building good product with, I guess, kind of very hot takey, but product with taste. So not just building everything that comes in, but trying to have an overall direction that you go in.
Yeah. I can imagine also, we serve similar audiences of essentially engineers that are using it. And I think engineers have a bias towards being like, I need this. And they have like a solution in mind. Like, well, as you said, like what's the problem you're facing? Like, let's see if there's something more holistic or a cross-cutting, right, that we could implement here.
Yeah, people think very solutions oriented. Equally though, developers being an audience, that's great. Developers are some of the most empathetic customers, I think, and people who really buy into the tools that they use. And you'll know it from Upsell, but it's like the people who are using your service really do love it, and they're really happy to sit there and brainstorm with you on how to evolve it. So ignoring that type of information and feedback would be just really silly.
For sure. So you gave an interesting talk over the summer, and I like it. Man, it had so many. I call them truth bombs. It was just such amazing content. I was wondering if we could touch on some of the points. One of the points, it was for our listeners, it was the growing into platform engineering talk at PlatformCon. And it gave a lot of just actionable advice on how, like, when you're starting with platform engineering, like actionably how to get started before you get to this like late stage, service catalogs and hundreds of engineers. Like, how do you get from like 0 to 1? One of the interesting points you brought up was how like platform software is it's just software. I was wondering if you could talk a little bit more about that.
Yeah. So most of this talk was, in fact, I think almost all of it came from my experience at GoCardless. I joined the SRE team at GoCardless when it was just 2 people, so 3 of us in total. And then by the time I left that group, I think the SRE team had broken into core infrastructure, which dealt with kind of like the underlying Kubernetes and everything else that was kind of running, keeping the lights on. Developer enablement, so developer experience team, data infrastructure, and a security team. So it was an entire like conglomerate of teams by then. But yeah, that meant that I have at least a couple of different stages along that lifetime where different types of work became relevant or appropriate for us to try and dig into. But it's also worth saying that I moved into SRE with a software engineering mindset, as in I transitioned straight from software engineering. So it should be no surprise to people that when I first turned up, some of the stuff that I saw as being a problem, I think is like normalization of deviance out of the way that people in SRE kind of think about their systems, or at least did back then. So some things were, obviously, we had this huge suite of Chef code base that was totally untested because tests just felt like they were a bit weird. And I think people had said to themselves like, oh, but we're provisioning machines, back then Docker didn't really support some of the underlying syscalls that you might need to do some of the provisioning. So they've gone, oh, well, our stuff is so special. We can't like run on a CI provider. So we can't have tests like the developers and stuff like that. But this is usually, I think, in my experience, just wrong. Now, you might need to do some horrible things to get it working. But you can definitely, as someone in a platform engineering team or just working on infrastructure in general, you can definitely start thinking a lot more like a software engineer and applying good SDLC practices to your code. So one thing, for example, that we found was really useful, we had a ton of scripts that we were asking people to run, and we had a bit of a distribution problem. So these are scripts that engineers internally to GoCardless would need to run to perform operational tasks. Getting those scripts to people turned out to be kind of difficult. We were trying to ship something to their machine and run it with the libraries on their machine. You didn't know if anyone was using the same version, all of that stuff. So what we ended up doing was we created, like with Go, as everything in infrastructure seems to be nowadays, like a Go command line interface that we called anew. We were into naming things after like mythical things back then. But anyway, anew was this one command where, using good practices from software engineering, we could implement the operational scripts that people needed across the org. And then we optimized for shipping that thing across to not just developer machines, but also into our infrastructure. So as soon as you would merge a PR on anew, we would build the Go binary, we build a container for that Go binary, we build a VM that had the binary installed on it, which was used as our base image across the infrastructure. We had the container image used as our base container image in Kubernetes, and we also cut like a new homebrew tap for that latest version. So if any developer had this tool on their laptop, they could just do brew, upgrade, anew. And this just like opens a huge number of opportunities for you, where before the bar to add like an operational script was too high for you to kind of try and solve something in an automated manner. You just go, no, we can't do this because it's just too much effort. Now it's super easy because you're just adding another command to an existing code base that has good patterns in it, and you can kind of copy and crib the tests from somewhere, so you're not trying to invent things from whole cloth. And it just means, frankly, that you can do more interesting things, and the stuff that you do takes less time than it did before. So yeah, it's like get continuous delivery from almost all of your stuff if you possibly can, and think outside the box when it comes to some of this, because yes, like I'm telling you that you can apply these patterns, but it might not quite fit in the same way that it does for software teams. That, I'm afraid, is part of the challenge of being in this environment, but it's definitely doable.
Yeah, it sounds like one of the major insights then was just making it predictable as to where new code should live, right? It was like, hey, there's already this repo, it already has this command structure, it already has tests. If you want to add another command, the bar is now much lower to do so, and you get all the side benefits of like good distribution through all the various package management systems you use and testing, and all the confidence that comes with that.
Yeah, and like autocomplete on the app as well. There's so much stuff that when you have one place to invest your time, the leverage that provides you when everything kind of lives there is just so much higher. So all these nice to haves become, it's no longer just nice to have, it would actually be really good to have. And if we do it once here, the cost is low enough that it becomes worthwhile. So yeah, get one place if you're trying to start a platform engineering team, get one thing that you need to look after, make it really good, and make it really easy for people to add to it. And then like the problems that you have afterwards are problems from success, not failure.
Right. The actual new script itself, was it more a dev tool that developers would use to like provision their own infrastructure, or was it more used for the kind of building and distribution of the kind of main Go Cardless apps?
So it didn't have anything inside it that would know about the Go Cardless platform as a whole. Okay. It was about how to interface with the infrastructure that we were providing to developers. So there was a deployment flow that the new script could run, and that deployment flow would know how to communicate with the right infrastructure to trigger a Helm deployment into Kubernetes, or send the right GitHub like webhooks so that we got deployment hooks, all of that sort of thing. So it was less thinking about the Go Cardless app as a whole, more thinking about I'm a kind of operations tool.
Cool. Now, another kind of activity you folks did at Go Cardless was you built your own sort of homegrown service catalog, this kind of list of like just what's out there. I was wondering if you could talk to people about why you thought that was an important thing to do.
Yeah, so one of the most challenging things that we did at Go Cardless was we originally started off in IBM SoftLayer, where we were renting actual physical hardware, which was painful because you had to wait for someone to scoot across the data center, maybe several hours later or even days, after your stuff had arrived, because maybe it wasn't like available at the start. But what it meant was we ended up migrating everything across into Google Cloud Platform, and as we did that, we adopted a whole host of new technologies. So we ditched our homegrown container management system, which was called Conductor, which actually I feel quite happy, I like that thing. It was quite simple. Kubernetes was a lot more complex. Obviously for more features, but a lot more complex. But we also moved all of our kind of chef infrastructure into a bit more containerized environment and everything like that. But the problem that we had was we had now unlocked GCP as an infrastructure tool for everyone across Go Cardless. And in a sense, we had been victims of our own success in that people were using this stuff quite a lot. And when they started using it, they started creating a lot more of it. And the foundations that we created when we migrated things across weren't necessarily as neat or as strong as we hoped that they should be. And it meant basically we ended up with a really big mess. And before we could tackle that mess, I think, and try and figure out how to improve it, one thing that I kind of figured out was that we'd have almost no hope unless we could understand what it was that we had inside of the system. So the service registry that we ended up with, which is like a service catalog back then, I don't think there were many people talking about service catalogs, so we called it a registry, and had to rename it, I think, later on in life. But the idea was that it was just going to be a huge database of almost every asset that we had inside of the infrastructure. And having that database of, say, every service that you have and all the environments that service was deployed to And then going from kind of this high level construct of an environment, which is a bit synthetic, to where was that thing deployed and how was it deployed? So was it in the old infrastructure? Was it in the new infrastructure? Was it a Kubernetes Helm deployment, or did it use the new like Argo deployment stuff? If you had that huge database of things, then you could start making really intelligent tools that navigated that structure and did the right thing. So just as an example, we had a deployment tool in a new, so that binary that I mentioned before. And previously you'd have to deploy to a specific Kubernetes context and namespace and release, because we were using Helm back then. Obviously, now that we're moving things around and we're trying to restructure and actually split our clusters, you have developers who are getting a bit confused now, because we are trying to do as a platform team or as an infrastructure kind of operations team, we're trying to move your application and we might be double running it in 2 locations, but how do they know where the thing is running? So when they're issuing the deploy command, what's actually deploying where? And you could end up in this weird situation where they've deployed to one environment and not the other, and that would just be really messy and horrible. So what we did was we created this service registry that mapped everything out. We built it as a JSONit library. If you haven't used JSONit, it's just a superset of JSON. It kind of it's like a templating language for config management, and it's quite good at doing this stuff. So we used JSONit and packaged up this big service registry so that Anu and all the other binaries that we had in our system could really easily pull the service registry from everywhere. So everything could access the data. Then we could build tools inside of Anu and otherwise that could do things that knew about where services were located. So when you issued a deploy now, instead of having to say, I'd like to deploy to this Kubernetes context, namespace, and release, you just say, I'd like to deploy this service with that environment. The tool would then go look up in the registry, where is this actually deployed, and it would know how to implement the deployment strategies for each of those locations. And it just ends up creating a much, I think, clearer boundary between you and developers in terms of where you're hosting your stuff and how they should think about the world. So they shouldn't really be thinking in terms of where you're moving stuff around. If, as a platform team, you're taking operational responsibility of the clusters that they run in, you should just be giving them a space, and they should just be thinking in terms of, I'd like to deploy the service of my app to wherever it is located. And this was really, really powerful, kind of surprisingly so. There were so many other things that we ended up doing with it. Even, I think we were provisioning inside of our clusters the Prometheus rules that would allow you to join labels from wherever your pod was running against a time series that told you what service and environment that thing was. So now you could roll up all your metrics against the service and environment in Thanos and not have to think about kind of where this stuff was, but it would be using the stuff that developers were used to querying against. Tons of other things too. So I guess the takeaway for me here was, if you ever find yourself with a sprawling mess of infrastructure and you want to do things like really tighten it up, move things around, or kind of ease the pain between the developers using your stuff and the people trying to look after it and move it around and caretake it in the background, having that level of, this is actually where we define where everything is, and a map and a database of where everything is super important.
Yeah. I really also like the observation around, like, it's the interface. Like, for the product engineers, their interface is no longer at the infrastructure level, it's at the application level, which is generally where they live. And then your platform folks can focus on the infra and like the underlying hardware, essentially, where those applications are running.
It's far less stressful.
Yeah. How did you keep the info up to date? Like, this is, like, years ago at PagerDuty, we had, it started as a Confluence page, and that quickly, went out of date. And then at the time, PagerDuty used Chef, and then they basically just auto-generated this list, but it was kind of just what's out there. It didn't really do the, like, who's responsible for it. How did you folks kind of think about that? Like, was deployment the stick of like, hey, if it's not in this registry, you can't actually deploy anymore through a new, or how did you, keep that data?
That was very much a thing that I realized at the start, which was I didn't want to have a registry or a catalog that was a kind of bookkeeping effort. So it was something away from the infrastructure and not actually used by the infrastructure. The way that we tackled this was we provisioned all of our underlying infrastructure from what we would derive from the registry. So we would have clusters, for example, Kubernetes clusters, where all of the namespaces were provisioned from what we could identify were services that would target that cluster from the registry. And we would also, alongside that, go for our permission model, we assign permissions relevant to your service to the person that is nominated as the owner, and we use Google Groups back then. So we'd be mapping in Kubernetes RBAC that says the owner of this service now has permission to operate the service, which really means kind of view everything and maybe restart pods and things like that. And then maybe you'd have like admin and stuff like that in the service registry, and that's how you get all of your permissions. We even did it for Google IAM. So we ended up, I think, in a really great place where we integrated Google services really tightly with our Kubernetes environment. And from a developer's perspective, all they thought about was, I would like to be an operator of this service, and we would allocate within the Google project of that service and within the Kubernetes namespace all of the associated permissions that they might need to operate the service that they were using. So I think that's where we kind of got this right, in that the way to do things was by adding it to the service registry. So it was quite simply not possible for you to end up creating some infrastructure that wasn't represented accurately in the registry, because that infrastructure could never have been created unless it was there anyway. And that simplified the whole thing, I think, and made it infinitely more powerful.
Got it. So the catalog wasn't like some overlay on your existing architecture. It was the authoritative source for what that architecture should be.
Yeah. And yeah, cool. If you don't build it like this, you will spend your time fighting people who just want to like get stuff done, who have kind of bypassed the system. And I think no one really wants to be spending their time doing that. So I think it's just better for you to do it this way.
Yeah, tie it in and basically automate it, whether it's automating the creation of the infrastructure from the catalog or somehow keeping that data up to date, automatically. What was the developer experience like? You mentioned this use case of like, hey, if you're an operator and you want to kind of take control, was it kind of just make a pull request against this JSON.NET file and then magic happens on, the Google IAM side? Yeah,
so I was really keen that for the way that our code base was structured. Firstly, we did have one big code base for the configuration of applications and all of our infrastructure stuff. That's something that I think a lot of infrastructure tools recommend nowadays, and I think is just generally a good pattern. It means you can share and reuse things, and especially for us where we were using JSON.NET across like lots of different places in the infrastructure, we could just load JSON.NET from a variety of other tools, and we could use it as the glue between a lot of the stuff inside of our infrastructure. But yeah, for us, the experience was for each service, we would template out a directory which said, this is the service. It would have a metadata.json.net within it. You then define, using our JSON.NET library, the thing that builds the service registry, you'd implement an interface which is I am a service, and it would ask you for things like who is the owner, who should be like operating and viewing this service, along with what Google services do you need, for example. Do you need Cloud SQL, stuff like that? And then you would define how many environments do you have and where do you want them to go. And then from that, within the same directory, you'd have some like overlays. So you'd have environments, and you'd have for each of your named environments, you'd define what that environment looks like so that you could kind of tweak things depending on whether or not you're in staging or production. And this was where you'd also manage application config, so environment variables, which kind of plugged into our secret manager. But the idea was that everything here was the config mix that you would apply to your code before you then ship that thing to a production environment. So for people in a team that owns a collection of services, they would have a code owners file that specifies them as reviewers. And then we'd have code owners on the stuff within the broader infrastructure. So inside of your environment, for example, you could say, I'd like this much resource for my namespace. And if you did that, then our cluster manifest would be loading in all of the different services, and it would then adjust the namespace annotations within our cluster project. But then because infrastructure were code owners of the cluster project, they'd be brought in on top of the review. So it would be both a review from the person who owned the app and also a review from the infrastructure engineer who needed to, make sure that we weren't about to give someone 2 terabytes of RAM or something for a React app. It was,
Cool. That sounds like a great way just to make sure that like both sides, kind of all parties that need to be involved in the deployment and development of the application are pinged.
Yeah, I think when I first joined the team, the SRE team anyway, I was sold on it from the idea that I quite fundamentally believe that developers who are running these applications should be given the ability to operate them. I think it's kind of, if it's not a predicate for DevOps behavior, it's definitely a thing that eases it along. And I'd also come from a background where I was not necessarily frustrated, but definitely slowed down by the idea that I'd have to go via a ticket to the infrastructure team to get something done. So my goal for that SRE team, which I thought naively we'd achieve within a year, was someone could turn up at GoCardless and they'd be able to deploy their app, and they'd be able to do that entirely independently of any help from the infrastructure team. So following like a tutorial, and it would just guide them through the steps, and they'd have all the permissions to find a safe space within a cluster that they could use to toy around with it, and they could do things without review, which I think is actually kind of important for their toy apps. They need to be able to play with it to understand the infra, to get the operational expertise to do things for real. And I think what we actually found was that worked really well with this system. So I've actually, if you go to the GoCardless blog, I think it's on Medium, they have, I think it's an article by me a while ago that is how we deploy software at GoCardless. And we open source the tutorial that we have for how you would deploy a thing using all of our tech stack. And it did get to the point where, as part of onboarding, you tell an engineer, like, one thing that you need to do in your first week is go ahead and just deploy an app into our infrastructure and make sure that you can get the little landing page that says, hey, I'm up and alive, and you can access it and prove to yourself you know how to use the infra. And I think that's a testament to this setup working really well, because actually that particular tutorial needed no input from infrastructure engineers for someone to go through. So we kind of hit the point where engineers could autonomously use the platform that we'd offered to them, which I think is something that most companies struggle to get to.
That's awesome. Like, yeah, it sounds like you guys finally found like the holy grail to let product engineers be productive. Yeah.
It took me and my team like many years to think this through, and we tried several things before landing on this one. But when we got there, it definitely felt better than all the stuff we'd had before.
Cool. What was the adoption like for a lot of this work? Like, was it did all your product engineers just flock like fireflies to the light, or were there inconsistencies? Like, how do you kind of measure product market fit of those platform engineering efforts?
Yeah, so I think I quite firmly believe that platform engineering can be aided by and really helped by good product management and just generally good product thinking. So this was one of the kind of the hiccups that we had when we deployed this stuff. We'd been talking with some key stakeholder teams, so people who have more operational requirements than most. Banking teams, for example, who were running big pipelines and things would often go wrong and they'd be on call for them, so they needed like the ability to debug them. These were obviously our what I would now call an ICP. It's what we talk about incident, our ideal customer profile. That meant that they were really engaged and willing to beta test all this stuff. But it also came with the downside that we kind of only heard the positive feedback, or at least the beta testers that we were using were the people who really wanted what we were building and were super enthusiastic and willing to kind of be early adopters in all the senses of that. So that they will put up with small bugs and friction points that other people won't, or you don't actually want if you're building a product, right? Like, you want the product to be seamless and remove all those friction points. If you have beta users who don't tell you about them because they don't mind, that's not going to be good. So what we found was we deployed the thing, and the beta users, or the teams who we've been working quite closely with, adopted it really, really quickly and were super happy and very keen to use it, and actually, just quite frankly, just very great to work with on it. And then we found that there were some teams across the organization who just frankly hadn't seen the point, I think. They didn't really want to migrate anything or put any effort into doing it. And I think at first we thought that this was kind of a bit of a product problem, as in the product that we'd offered them wasn't it wasn't good enough, or like we hadn't built something that was usable. But by the time we dug into it and actually really had some hard discussions, we realized that those teams were very much in the mindset that even though we'd offered them a product here and allowed them to do a whole load of things that before we thought were annoying for them because we were doing them, some teams at least were of the mindset that actually it was great that you used to do them for us. And even though we said we wanted them to be done faster, it's kind of, we didn't want you to give us the tools to do them. We just wanted you to do them faster. So obviously that was a bit of a, it was a bit of a realization. But had we been a lot more connected to the rest of the org and been a bit more aware of our blind spots in terms of who we were using to test and where we were getting feedback from, something that I think good product kind of sense and common practice helps you do, then we probably would have been able to head this off earlier. And whilst we did resolve it in the end and had some of those hard discussions about what's expected of people in terms of operating their app, it would have been easier if upfront we had, for example, communicated a bit more clearly about what the expectations were, how the world would change when we deploy this thing. Everything that you can expect would have made things better.
Yeah, I empathize strongly with the selection bias of finding, customers that really want what you're building, so they're willing to overlook a lot of the pain. And it sounds like actually a difficult challenge at the end there, like they don't want self-service, right? They just want you folks. They want the status quo, just faster, and not realizing that there's a better solution, which is self-service and kind of like push versus pull.
Yeah, and I think that's like an engineering leadership challenge, or actually just truly management. That's like aligning expectations with what the company expects of you in your role. And yeah, there's a part of this that is, as an org, we needed to rearrange a bit, but the other end of it was we just could have detected it sooner had we been a bit more dialed in. So,
right. Yeah. So basically, I think you mentioned it, like focusing platform engineering efforts with like a product management mindset. Like, who's your customer? Who's your ICP? What are their problems? What does the future state look like? Are they bought into that future state?
Yeah, and I think product management in infrastructure is really hard sometimes. So I'm sure she won't mind me naming her. So I worked with probably the best product manager I've ever worked with, Ali Hickson at Go Carlos, and she joined the SRE team at a time when we were doing very kind of deeply intense like technical stuff. And Ali didn't have like a super technical background, but her value of bringing, or what she brought to the team, was the ability to create stories and narrative around what we were doing and gain the customer insight and the feedback that we needed to actually perform and deliver something that people wanted. And I think having had much more dysfunctional relationships, I think, with products especially from within an infrastructure environment before, where I think product management can often be a bit of I've been dropped into a team where everyone knows about all this stuff and a lot of the decisions are made using technical context that I don't have, so where can I have my value? That can be a very difficult thing to navigate if you're not super confident about where you're delivering impact as a PM. And I think Ali did this extremely well, where she could really find the places that she was adding value. And then when she did, suddenly it was kind of night and day for the team, I think, in how it felt and how well organized we were and how much more direction we had in terms of the strategy that we were taking for the infrastructure. So it's kind of, I empathize a lot with people where they may have had burnt fingers before, where product has come in, especially around infrastructure engineering, and you've kind of butted heads, but I'd advise people to really go back to the drawing board, especially if you're taking on more of the platform engineering side of things, where you're offering a product to people. Product management is actually a discipline, and it's really, really good, and you can learn a lot from each other. Nice.
I have one other topic I wanted to cover with you today. This is more recent, but at Instant.io, I know you folks have been looking a lot at like kind of metrics and how you folks think about how teams should evaluate incident response processes. There's a lot of literature that's like, oh, just MTTR and that's it. And I think you folks have an opinion that like, no, there's way more than just MTTR and we should be looking deeper. I was wondering if you could talk a little bit more about that.
Yeah. So this has been on my mind for the last couple of months as we've been going back over what we call our Insights product, which is where you're running all your incidents on Instant.io. We obviously have the data about your incidents and how they are run. We want to offer you insight into how those incidents are going. I built the first version of our Insights product, I think, about 6 or 7 months ago. I'm fairly happy to say I think it was really crap. it was not good. And when I say that, I mean it wasn't good in the sense that I couldn't look at those metrics and understand or learn new things about my organization from looking at that data. They gave me kind of surface level things on, okay, well, there were more like dots on a graph for each incident that may be colored, or larger dots for how severe the incident was or something like that. But it didn't give me a true understanding of kind of the stuff that I care about, which is where is the workload coming from? Like what's causing us to be working more? Which services are they? Like what teams are under more pressure, for example? And I think the cool thing about this is that when it comes down to the industry and what they're looking at in terms of incident data now, the SRE book kind of introduced this concept of MTTR and MTTE and all the kind of mean time to measures. But we're realizing slowly that those measures are really poor at reflecting what truly matters when it comes to incidents. Quite simply, means are really, really bad at this. They will be substantially impacted by the really bad incidents, and they won't
by extremes,
necessarily exactly. So they won't necessarily reflect it when, as a whole, your organization has got much better. You will just simply be as bad as your worst day, if that makes sense. And that's not very good for understanding anything. And actually, it's mostly only used in a reporting sense. So you'll find these numbers appear in quarterly reviews with executives, and they'll want mean time to whatever for each of your orgs. And that's not very good at understanding things properly. So the cool thing is, I think we've kind of, after fiddling around with this for a while, found something that is a lot more valuable in terms of what we offer to people. So the first measure that we've been working with was trying to quantify workload over an incident. And I think this is one of the ways that we as an incident platform can break through kind of the next stage of MTD X is rubbish, but we don't know what to do next. It's like, well, these people who are very, very smart might not know what to do next because they simply don't have access to the data that we do as an incident platform. So when I first joined Incident, I was super excited about the fact that we can get a pulse of the activity over incidents. So we see when people are messaging in a channel, we see what happens over all your integrations when you get paged in PagerDuty, when support agents are dealing with Zendesk tickets. We've got a huge web of information that gives us a really holistic picture over how your organization is responding. So one thing that we've done is we've taken all that activity and turned it into this synthetic measure of working hours. So we've assumed that if you've worked on an incident or had some activity related to an incident within a short period of time, we'll basically take that as a contiguous period of work that you've done on that incident. And then what we can do is we can estimate for all the users in all the incidents that you apply your filters for, how much work actually went into them. And then using the tags that people have against their incidents, you can then split that workload up by things like team. So you can see which teams are working most and how that's trending over time, or maybe service, or even in some cases, like I've seen some of our customers who may be dealing with customers in different regions, they'll tag incidents with the regions that are affected. So over time, you can look at this graph and go, oh, well, that kind of makes sense because we had a burst in like European incidents, and that does make sense actually because at that time we were rolling out this new product feature. Or maybe it was, you can now quantify what the operational effect was post a launch of a feature, because you can see how it affected the workload over time that comes immediately afterwards. And I think this is just one of the ways that you can really dig into this data in ways that I think it's the first time that I've looked at these incident graphs and gone, oh, actually, this is super interesting. And like you want to dig through because it keeps telling you more about how your organization is performing. So yeah, we're going to be kind of riffing on this for the next couple of months anyway, and well, probably for longer too. But I'm really excited, and the response that we've got from customers recently has been, oh crap! Like yeah, no, I didn't even realize this. Like I keep kind of digging into it and finding more stuff that I didn't know was there, and that's really exciting for me.
So it sounds like then it's less about just this one packaged number like MTTR, and more about like understanding kind of the total time impact, but sliced by team or by geo or in time to see if you can correlate it to other things that were going on like product releases.
Exactly. And then, I mean, you'll be very familiar with this from your time at PagerDuty, but one thing that we're working on, I think probably next week, is we get a lot of information from paging providers, be it PagerDuty, Opsgenie, Splunk, whichever. We'll know when people are paged, and we also know what time zone they exist in. We can create quite an effective measure of whether or not people were paged in hours, out of hours, at unsociable hours when they should have been sleeping. So you can come up with this view of how kind of disproportionately your pager load is spread across the org, and if there is anyone who has recently been impacted more than they probably should within some thresholds of your organization. And you can do some really interesting things with that. So you could use this as a graph over time to debug whether or not your on-call rota is staffed correctly, but you could currently proactively warn engineering managers about people who should probably actually like get cover for their shift because they were paged 5 times last night. They barely slept. Like tell them to go home rather than come to work and be a zombie. And I think that this is where the exciting part comes from. It's taking this like very academic and scientific MTTX whatever it is, the single stat that you have on the board, and turning it into a really rich interpretation of the human aspects of incident response. That's what I'm really excited about, and the stuff that seems to be resonating really well with our customers.
Yeah, for me, I think a lot about, incidents ultimately are like a distraction. It's like you have your normal course of business and all of a sudden this thing comes out of left field. Now a team or a bunch of people need to go kind of respond to that. And so I really like a lot of the thoughts you have here on like, it's try to get a better measure of like, what was the distraction coefficient? Like how much time did we spend not doing our core thing and doing this other work as opposed to just MTTR? Because then in addition to like, mean is not a great classifier. There's also questions on like, did the incident actually start when the alert system fired, or was it like smoldering for longer than that? Like, how did you actually like dig into that detail? Did it finish when we hit resolve, or was there like follow-up work? You know, we solved the burning problem, but did we actually like fix some underlying architectural issue that was causing it? There can a lot of time be like that trailing work at the end. And that never really, I haven't found a great system that captures that kind of pre and post work.
Yeah, exactly. And I think as an example of an insight that I think was really smart. So I've been doing all sorts with data to try and find out what works here. One thing that I experimented with a while ago now was getting a network of interactions between people by which incidents they end up sharing with and how much they've interacted there with all the other
like
people.
Like a clique almost.
Exactly. So then you build a network of your entire org, and then you run it through modularity, like community detection algorithms. And what you do is you end up separating it out into communities. And if you go show that to a CTO or someone who is in like like director leadership, whatever, what I actually did was I found one of our customers and showed it to them, and they thought it was very interesting that they have a group, which was like a group of teams. Who they've been recently questioning whether or not like it makes sense for them to be a group, and the modularity or the community detection had like cut them straight in half, like down the team boundaries. And it was a realization for them that actually these people are doing work like we thought this, but these people are doing work that is just totally separate from each other in terms of the impact and the collaboration that they have, and stuff like that is that's real insight. That's really, really interesting. You're
using data to almost like drive your org and your hierarchy.
Yeah, and I think it's kind of it's Conway's law, right? Which is like eventually your code will reflect your organizational structure. I think it is like that on steroids with the social network effect of what you get with incidents. It's like really when the chips are down, who is working with who and how much. And yeah, I'm really excited about what we can do with that.
Cool. Lawrence, this has been just an awesome conversation. Before we wrap up, I always like to ask, what's your favorite music to listen to when you want to do work or have kind of any focus?
Oh, yeah. No, that's I tend to listen across all sorts, but eventually I'll end up with some drum and bass. And I'll get ripped for that by several people on my team who will laugh at me head bopping along. But yeah.
Own it, man.
Yeah, that's good advice for anything, I think.
And what's the best way for people to kind of follow you on social media? I know you're pretty active on Twitter.
Pretty amateur on Twitter, but I think my blog, so blog.lawrencejones.dev, that's usually where I end up writing about this stuff. Quite like going back into the stuff that I've done before and thinking about the lessons learned and kind of recontextualizing it against what I know now. So if you're interested in this type of content or just generally engineering stuff, then I would go there. And then obviously Twitter is where to get me if you want to if you want to send me a message or do something else.
Cool. All right. Well, listen, everybody follow Lawrence on his blog and also on Twitter. Lawrence, man, again, it's been absolutely great having you. Super appreciative of taking the time to talk to us today. For our listeners, also thank you for making it with us to the end of the episode. We've learned about treating platform software as just software. We've learned about the value of a service catalog. We've talked about product market fit for platform engineering teams. And we also talked about like better metrics than just MTTR for incident response. So again, thanks everybody for listening. If you have any topics or guests you'd like to see on the show, please send us an email at levelup@opslevel.com, and we'll see everybody next time. Happy building.
Amazing.